Hi gang, so now that we've finished section 1.5 in divisibility rules, where we learned how to divide a number or to know if a number is divisible by 2, 3, 5, and 10, we're moving on to section 1.6 of decomposing a number into prime factors. And for this, you will need to know section 1.5, so make sure that that has been reviewed and that's all solid knowledge. First thing you need to know are what does it mean prime and what does it mean factors? Make this a little bit clearer. Here is an F. So prime. If we have a prime number means it's a number that it's only divisible by 1 and itself. So for example, if we take the number 7, we can only get the answer 7 through multiplying 1 times 7. There's no other way to get 7 with whole numbers. So 13 would be another example. 1 times 13. You can't do 2 times or 3 times or 4 times or 5 times. None of those work here. And so how do I know that? I can take, for example, my divisibility rules of 2. Look at my last digit. Is it a 0, 2, 4, 6, or 8? Nope, so it's not divided by 2. If I take my 3 rules, so I do 1 plus 3, that equals 4. That's not divisible by 3. It's not a 5 or a 0, so it's not divisible by 5 or 10. So here I know that 13 is a prime number. This is compared to a composite number where we take example of a number 12. 12 I can do 1 times 12, but I can also do 2 times 6. I can also do 3 times 4. So there are different ways of getting this composite number. And this we've already done an activity in class to see this. So that's what it means to be prime. We need to get down to prime where it cannot be broken down anymore because that number and 1 are the only numbers that work into it through multiplication. A factor, well actually I'll leave this here. A factor is the numbers we multiply together to get a number. So the factors of 13 are 1 and 13. The factors of 7 are 1 and 7. When we had 12 here, we had 1 times 12, 2 times 6, and 3 times 4. 1, 2, 3, 4, 6, and 12. These are all factors. You can multiply. It's 2 numbers. You multiply together to get a product. Okay? So now we need to break things down. What this chapter is talking about is how to break larger numbers down so that at the end, all we have are prime factors. I don't want, example, 6 here because 6 isn't a prime number. 2 is a prime number, but 6, I could further break that down into 3 and 2. So 6 is not a prime number. So I'll give you an example. Just like the one that I have in the book on page 26, they have the number 42. So 42. The first thing I need to think of 2 factors that will multiply together to give 42. So I can go through, I can do 1 and 42, okay, 2 and 21, okay. And I get up there, but I know my times tables. I can look at my reference book if I need to, and I will find that 6 times 7 is 42. Now, like I said, there are multiple answers because you could have 2 in there, you could have 21 in there. So I'm going to pick 6 and 7 for this example. There are other ways to do it, but this one will work well. So now I have to look. Do I have any prime factors in there? Yes, I do. I have 7. 7 is a prime factor, so I'm going to keep that there. But 6 isn't. I can break down 6 again. Now I could do 1 times 6, but that doesn't get me any further because I still have a 6 here. So I can do 2 times 3. 2 times 3 is 6, and then 7 times 1, that's 7. Okay, so I've broken it down again. So now, can I break down 2 anymore? Nope, it's a prime number. The only numbers I could break it down to are 2 and 1, so I don't need to repeat it. 3, I could break it down to 3 and 1. But see, if I were to do that, I would have 1 times 3. Oh, well, 1, I can do it again. 1 times 3. And it would continue, so it's useless. I don't need to do that because I would just go on forever. The idea is that a prime factor can only be itself and 1. And 7 as well, I can only do 1 times 7. So now I have my 3 prime factors that if, and If you have a calculator, you can check. If I go 2 times 3 times 7, this is equal to 42. So these here are my prime factors for the number 42. Let's take another example. I'm going to work over here. Let's take the number 24. Okay, so I have the number 24. Now, in my head, I want to think of what are the different factors to 24. So maybe over here on this, I've got some space over here. Over here on the side of my paper, I'm going to think, how can I get to 24? I can do 1 times 24. I can do 2 times 12. 3 times 8. 4 times 6. So all of these are factors of 24. 1, 2, 3, 4, 6, 8, 12, and 24. All of those are factors of it. So I'm going to pick one. I'm going to start with, and it really doesn't matter which one you pick with. I'll do another example to show you, but it all works out to the same thing. So I'm going to start with my 4 and 6. I'm going to take my 24, maybe move it over a little bit to have some more room. So the first thing I'm going to do, I'm going to break it down into 4 times 6. Perfect. Are those prime factors? So these are factors, but are they prime factors? Nope. My 4, I know I can break it down to 1 times 4, but also 2 times 2. I can break that one down 2 times 2. What about my 6? Like in my last question, I will 3 times 2 is 6. And don't forget to write your times each time, because it's not addition, subtraction, division that we're doing. It's always times. Factors are what we're talking about. We're talking multiplication. Now, can I break these down anymore? No, only 2 and 1, 1 and 3. So 24 is equal to 2 times 2 times 3 times 2. Okay, so those are my prime factors. If I did it another way, because there you saw I did 4 times 6. But what if I didn't see that right away? What if I wanted to do, what if I saw 3 times 8? What if I do 3 times 8 was a factor? Let's try it again. So here I'm going to do 3 times 8. So I'm doing the same thing, but just picking different factors off the start. So now 3. 3 is going to stay the same. 3 is a prime factor. I can't break it down anymore. However, 8 I can. 8 I can do 2 times 4. 2 times 4 is 8. Okay. Oh, my 4 I can break it down. Oh, I forgot my times here. Here I've got 2 times 2, and I guess I should actually have the times over here. So I can do 2 times 2. Now my 2 stays here, my 3 stays here. I have the same thing. I have 3 times 2 times 2 times 2. 2 times 2 times 2. So I have 1 3, and I have 3 2s. So it works out. If I wanted to do it another way, maybe the one that comes to mind is 2 times 12. Let's try it. 2 times 12. 2 is a prime factor, so I don't need to break it down. 12, I can break this down to 2 times 6. 6, I can break it down. 2 times 3. So again, I have 2, 2, 2, and 3. So I have to, I'll bring this one down. Bring this one down to my middle row here, and then to my final row here. So again, I have my 3 2s and a 3. Now the final thing is that I can write it in an exponential notation. So this is something we touched on last time. I know some people had some difficulty with it, so I'm going to explain it again here. So I have 24. Here, I'll erase this one over here just to have a little bit more space. So at the end here, I'm going to continue. 24 is equal to 2 times 2 times 2 times 3. Okay? I can rewrite that. How many, so we notice here that I already have 3 2s. So I can write 2 to the exponent 3, or 2 cubed. because I know that I have 3 2's. It's not 2 times 3. I have 2 times 2 times 2, and I have 3 of them. And then I need my 3 here times 3 like this. So 24 is equal to 2 cubed times 3. And that is how you factor, you do prime factors, and this here is the exponential notation. Good luck.